I'm Maisie Schaffner. I go to Edward R. Murrow High School, and in my experiment, I studied the effect of magnesium sulfate on the growth rate of Gleocapsa algal culture for the production of electricity and the absorption of carbon dioxide indoors. So, fossil fuels are the world's main source of energy, and because of this, pollution is increasing at a dangerous rate, more specifically, carbon dioxide gases. So, in my experiment, I attempted to capture CO2 from the atmosphere with Gleocapsa and use the same Gleocapsa to produce energy in the form of electricity. So, as you can see in the diagram, global warming is being caused by an entrapment of heat in the atmosphere due to greenhouse gases such as CO2. And on the bottom is just an up-close look at Gleocapsa, which is the genus of cyanobacteria I chose to use. They're bacterial cells that produce energy through the photosynthetic process. So another keyword is magnesium sulfate. It's a chemical compound that is a salt and a metal sulfate. Next is an electrolytic cell, which consists of an anode and a cathode. In my experiment, I used this to measure the energy that the Gleocapsa was producing. And lastly, we have carbon dioxide gas, which is a high-density gas, which consists of a carbon atom and 2 oxygen atoms. So I hypothesized 3 things. I hypothesized that by adding magnesium sulfate to Gleocapsa, the growth rate would increase. I also hypothesized that the magnesium sulfate would make it so that the Gleocapsa would be able to absorb higher levels of carbon dioxide. And lastly, I hypothesized that by adding magnesium sulfate to the Gleocapsa, the algae would absorb the metal and then conduct more electricity when tested in an electrolytic cell. So here are my materials and methods. I set up 2 tanks, one with just water and algae, and the other with water, algae, and magnesium sulfate. That's what they look like over time. And I measured every single day the temperature, the pH, and the growth rate, which I used a spectrophotometer to do. Then I used a multimeter set to 200 millivolts, connected to my electrolytic cell, and I found the voltage that each culture was producing. And lastly, I titrated both groups, which basically meant that I split the algae into test tubes, let them sit, and then I extracted the gas, I dissolved it into water, and then I used phenolphthalein indicator to test how much of the carbon dioxide in the air had been absorbed. So here are my results. As you can see, Gleocapsa's life cycle stayed the same in terms of the life cycle trends, but the magnesium sulfate increased the growth of cyanobacteria by a lot. So next, this is the voltage that was produced. The experimental group is producing electricity at a higher rate. And lastly, my results for the CO2 concentrations were that the control actually absorbed more CO2 than the experimental group. So basically, magnesium sulfate in my experiment I found to be very effective in increasing the growth rate of Gleocapsa as well as the production of electricity in an electrolytic cell, but it was ineffective in increasing carbon dioxide absorption rates. In fact, it actually decreased the amount of carbon dioxide that the Gleocapsa absorbed. So ultimately, in any future studies, this technique of using metals to stress the algal cells as well as to produce electricity should be used only to increase growth and electricity production, not to have an increase in carbon dioxide absorption. And finally, I want to thank Ms. Chan and Ms. Franco, and thank you for listening.